today we're going to start by solving systems of equations by substitution. And I'm going to give you something I think is very easy, but I want to see where we are with it. If A equals B and A equals C, then what else do we know?
B equals C.
Then I can tell that B equals C because B substituted in for A because they are equivalent. Okay. So we're going to use that thought process to solve these systems. If y equals negative 2x minus 7 and y equals 2x plus 17, what else do I know? Trevor.
X plus 17 equals negative 2x minus 7.
So if y equals this and y equals that, then this equals that. And now, what do you notice about our equation that we've just formed? We can solve for one variable. We can solve for x. So remind me from our Unit 2 solving equations, what would I do first to solve for x? Cal? I'm going to add 2x to both sides. Remember, we're going to deal with our variables first. So I get
4x plus 17 equals negative 7.
Okay. Next step.
17 4x plus negative.
So 4x equals negative what? 24. So x equals negative 6. Could divide by 4 on both sides. X equals negative 6. What do I do with that information now that I have it? I can plug it into either equation. Okay? So you could say y equals negative 2 times negative 6 minus 7. Or you could say y equals 2 times negative 6 plus 17. Either way you do it, what does y equal? 5. So how do I write my solution?
5 equals negative 6.
Remember, the solution to a system of equations is the point of intersection. So here's a point. So let's look at a second example. If x equals negative 4y plus 1 and x equals y minus 4, what do I also know? So now I have substituted in one equation for my x, so I don't have an x, I only have y's. And I can solve for y. What do I do first? Add 4y to both sides. And then add 4 to both sides. If y equals 1, you can plug it in. So x equals negative 4 times 1 plus 1, or x equals 1 minus 4. In either case, what does x equal? Now, what do you think is the number one mistake that students will make after they've done this problem? They've done all the correct work. Everything looks great. And then, what's the mistake they make in the end? They put the y value in the x value spot for the coordinate because they found it first. You need to be very careful when you write your point. How would I write this point of intersection? And then box your answer. Now these were easy because y was isolated in the first problem. X was isolated in the second problem. But what happens in examples like these? The best time to use it is when one variable is isolated or easily isolated. In this system right here, what's isolated?
By itself.
I don't see an X by itself. What do I see by itself? I see a Y by itself. What do I see isolated in this one? X. X is isolated. What do we see isolated here? Y. What do we see isolated here? Is there a variable that's isolated? So that's where that or easily isolated comes in. If it is something with a coefficient of 1, we can easily isolate it. It would be Y. Whereas both of these were isolated, we just had to set them equal to each other. Here, we only have one isolated variable. So I can see that Y equals X minus 2. So what I'm going to do is I'm going to take that and I'm going to use that in the second equation instead of using Y. I'm substituting this information in for my Y value in the second equation. So I start with 2x plus 2, but instead of writing y, what am I going to write? X minus 2. And the parentheses are very important. Unless it just has plus y by itself, you're going to want to use parentheses.
Times X minus 2.
Because it's times, right, like it's 2 times y, so it's 2 times x minus 2. Equals what? 4. And now we solve for what? What are we solving for? X. What do we call it when we're doing this? Distribute. 2x plus 2x minus 4 equals 4. What do I do next? We call that, what do we call that?
Oh, combining like terms.
Combining like terms. Good, Wilson. So we're combining like terms. 2x plus 2x is 4x. And now we can do our 2 steps to solve. What does x equal? So if x equals 2, what is y? You just plug in 2 for x. 2 minus 2 is 0. So y is 0. And double check that that point works in both equations. 2 times 2 is 4 plus 2 times 0. So 4 plus 0 equals 4. It works. We're going to do this again. X equals negative 4y minus 4. 3x plus 5y equals 2. So we are going to replace x. We are going to substitute in for x. So we're going to write 3 times negative 4y minus 4 plus 5y equals 2. What do you do first? You will always have to distribute, unless it just says plus x, and it's not going to most of the time. So negative 12y minus 12 plus 5y equals 2. What do we do next? Combine like terms. I have y's. So negative 7y minus 12 equals 2. Plus 12 to both sides. negative 7y equals 14.
So y is negative 2.
Divide by negative 7, y equals negative 2. Take that information, x equals negative 4 times negative 2 minus 4.
4, x equals 4.
So x equals 4. Double check. 3 times 4 plus 5 times negative 2. Does that equal 2?
Yes.
Good. So what is my solution?
4. 4 common negative
4, negative 2. Alright, so you have two problems that I'm going to ask you to try on your own. When you get done with them, we're going to walk around and check and see how you're doing. On this one, since it's not isolated by itself, you can change this, you can manipulate it to make it by itself. So instead of using this equation of 2x plus y equals 3, I'm going to use y equals what? Very nice. Okay. So try A and B, and when you have your answer, raise your hand. All right, who can tell me the equation I would write after substituting my y? Cal.
x minus 2 parentheses negative 2x minus 1 equals 12.
Great, because y is here and this is what y equals. Okay? When you distribute, something I saw multiple students forget is a negative 2 times a negative 2x is going to be positive 4x. Combine like terms. Subtract 2 from both sides. X equals 2. Plug that in. Y equals negative 2 times 2 minus 1. So y equals negative 5. 2, negative 5. Who can tell me the equation I will write after substituting in my y expression? Parker.
Negative 3x minus 7 parentheses negative 2x plus 3 equals 1.
So because we solved for y for the second equation, we have to plug it into the first equation. Combine like terms. Add 21 to both sides. X equals 2 again. Plug 2 in. And I can plug it into either one of these equations. You might want to go back to your original. You could use this one, but you want to check. So what does y equal? So it'd be negative 1. Okay. So 2, negative 1. All right, you talked about some special cases on Wednesday when you were graphing. What were the special cases? What were your two possible special cases for this? Jack, what was one?
No solution.
No solution. And when it was no solution, what kind of graph were you looking at? Parallel lines. They never intersect. What was my other special case, Adeline?
They're the same line.
When they're the same line. And what do we call that? What's the solution when it's the same line? Infinitely many solutions. We can't say all real numbers because that is a plane of the entire coordinate grid. But we're not looking at the entire coordinate grid. We're looking at a line, and it happens to be the same line, so the combination matters. So we're saying infinitely many solutions. We could name a couple, but we're going to say that there's infinitely many. So let's look at these in the examples of substitution. So here's y, and it equals negative 3x plus 4. So I'm going to substitute that in my second equation. So 6x plus 2, parentheses, negative 3x plus 4 equals 7. Distribute. What's going to happen to my variable? going to cancel out. And when we have our variable canceled out, we are left with a special case. In this case, 8 equals 7. Is that true? No. If that's not true, what's our answer? There are no solutions. These lines are parallel. -3. Good job, Ford. Just to call back to your parallel perpendicular lines from last week. All right, in this case, y equals 3x minus 6. So we're going to substitute in for y. This is the only time you don't have to distribute, when you're substituting into a value where the coefficient is a positive 1. Because this is a special case, what do we see? The variables cancel out. Is that true? So what is my answer? Infinitely many solutions for this system of equations. So those are today's notes. Are there any questions?